All right, now we want to talk about what are simple machines. So normally when I say the word machine, you might have in your head the idea of like a bulldozer. So that a machine has to be a very complicated device. Well, actually it doesn't. So what we want to talk about are simple machines. And so these are the six most basic, simple machines that we use. And all of these machines date back to antiquity, so that even the ancient Greeks were aware of all of these different kinds of simple machines and then what they can do. And so the simple machines are the lever, and another name for that would be like the teeter totter. Okay, then you've got the pulley, you have a wheel and an axle, you have the inclined plane, you have the wedge, and then you have the screw. Now, I encourage you as we're going through these different kinds of machines, there is a video that is excellent in explaining this. And so it's Eureka. So back here, when we talked about the videos that were available for this particular subject, one of them was called Eureka. And so this is produced by Canadian PBS and it's animated. And you might think that it's kind of silly, but the episode on simple machines is very good. And this video is only about 10 minutes long, and it will go over the inclined plane, the lever, the screw, and the pulley. So I highly encourage you to watch that little video there. So let's go back to where we were at. So here are again the different kinds of simple machines, and notice that 3 of them are highlighted. So you have the lever, the pulley, and then the inclined plane. So those are the 3 that as a student of mine you will need to know for the exam. So you definitely need to know how the lever works, the pulley works, and then the inclined plane. Now I'm going to go through them all just so that you can see how they work, but those 3, the lever, the pulley, and the inclined plane, that's what you're going to be tested on. So we need to have a definition. So what is the definition of the simple machine? So a machine is going to increase the force that you can apply. So you're going to put a force, a push or a pull, into a machine, and then the machine is going to exert a push or a pull. And so a machine can increase the force that comes out of the machine, or it could increase the distance that comes out of the machine. Now I'll explain what that means in just a moment, but it can either increase the force or it can increase the distance, but not both at the same time. So you have to make a sacrifice whenever you're using a simple machine. Also, notice it does not make energy. So in other words, if you put energy into a machine, you're always going to get out exactly the same amount of energy out of the machine. So a lot of people think you put energy into the machine and the machine magically makes more energy. It doesn't, because that would be contradicting which law of thermodynamics? The first law. So the first law of thermodynamics is going to say that whatever energy you put into a device, that's the amount of energy that comes out of the device. And it's worse than that, because according to the second law of thermodynamics, you're actually going to get out less energy, useful energy, than what you put into it. So don't say on the exam that it makes work easier or it increases your energy. So it doesn't. So the amount of work that you're going to put into the machine is going to actually be greater than the amount of work that you're going to get out, because some of the work that you're going to put into the machine is going to be turned into heat. So how does a machine work? It's very simple. Work in equals the work out. Now this is in an ideal machine. So in an ideal machine, which doesn't exist, but we're going to assume it does, in an ideal machine, you're going to put in a certain amount of work and you're going to get out the same amount of work. So the energy that you put in is going to be equal to the energy that comes out. So what is the definition of work? So work is going to be force times distance. So you're going to put into your machine a certain amount of force over a certain amount of distance, and then what comes out is going to be a new force multiplied by a new distance. And normally the idea is you want to put in a small force, and then what comes out is going to be a big force. So that's the goal normally for a machine. But we're going to see some examples of where you actually want to increase distance that comes out of the machine. But we mentioned that in a real machine, some of the energy is going to be wasted in the form of heat. So that means that the work that comes out of the machine is always going to be less than the work that goes into the machine. And if you take the ratio of those two numbers, the work that comes out of the machine divided by the work that goes in, that's going to be a number less than 1, which means that the efficiency of a machine is always going to be less than 100%. So we're not going to do a whole lot with efficiency in this course, but if you take a more advanced course, you would find that you would be able to calculate the efficiency of your machine. Okay, let's take a break. When we come back, we're going to begin our tour of simple machines by talking about the lever.